Okay, this is part 3 of the camp stool tutorial. So in part 1 we did the basic design of the kind of main section of the camp stool. In part 2 you learned how to replicate and assemble and do a photorealistic rendering of your camp stool. And in this part we're going to talk about how to prepare this file for cutting on the Crawlbot. Now, as we kind of discussed at the end of part 1, we saved out this file so that we could come back to just this core component. And the reason we want to do this is we are going to be cutting several copies of this file. And so you may be wondering, well, why don't we just cut all of them at one time? And that certainly is possible. The reason why we cut it kind of one at a time is that if there's any error or issue with one of your cuts, instead of that issue propagating across all the copies of your cut, it just happens in that one instance. So for example, if you didn't have the settings right, that wouldn't affect all of your cuts and ruin an entire piece of MDF, but rather it would just ruin that one, and then that's fine. You can kind of fix it, or you can cut another one. And so for this, we're going to just set up our Crawlbot file for one section with its 4 inserts, and that's how we're going to cut it. And then we'll cut multiple iterations of these to be able to create the entire assembled chair. So one really important thing to check before we jump into the CNC cam operations is making sure that all your pieces are flat. When we go to cut them, we need to see that there's no piece that's floating above, up in the air, or down below. If there is, you'll need to make sure that gets placed down on the ground. They all need to be on the exact same plane, at the exact same height. If you don't do that, there is going to be issues because we're only cutting with a 1/2 inch piece of MDF. There's nothing below it or above it that you're going to be able to cut with. So, do just make a quick check to make sure that everything, these 4 little insert pieces and this body piece, are all just on the same plane, and that they're nice and in line with each other. So what we're going to do is we have this go ahead and saved. We're going to go up to Model, and we're going to come over to Cam. And what Cam is going to do is it's going to help us create the file that is necessary, that our Crawlbot is going to understand to be able to cut this out of MDF. The very first thing we're going to do is we're going to create a new setup. So we'll come up over here to Setups and click New Setup. And the first thing we have to do is kind of set up our work coordinate system. This is kind of what is the X, Y, and Z axis. You'll remember in part 1 that I had you change your up orientation to be the Z axis. And this is important because the Crawlbot is a Z up oriented axis. And so what we're going to do is we're going to kind of tell this where the corner of our work is. The way that we can do that is by clicking down here on kind of this bottom left-hand corner. And what you should see is that the x-axis runs along this edge here at the bottom, the y-axis runs along this bottom edge, and then the z is running straight up along this edge. And that's how, when you set up the Crawlbot, how it's also going to be oriented. If we come over to our setup menu and we click over on stock, we are going to change the stock offset mode to no additional stock. This means that the build envelope is going to be constricted strictly to what we've designed here today. And you can see that the final dimensions on mine are just over 11 inches, 11.6 inches for depth, and then the height is 0.5. So this is good because our X and Y need to both be within 12 inches. That's kind of our maximum build envelope. And our Z must be exactly 0.5 inches. If it's a little bit above that or a little bit below that, that's not good because we are cutting with exactly 0.5 inches of material. So we're going to go ahead and click OK here. Those look good. And the next thing that we're going to do is we are going to work on designing the cuts that it's going to make. Now, there are a variety of cuts that we can consider. In this tutorial, we're going to talk about just one, and this is called a 2-dimensional contour. And what a contour is good for is it's good for being able to cut all the way through the material. If you're just wanting to cut into the material a little bit, that's called a pocket. That's up here, and that will be discussed during another project and another tutorial. But for today, we're going to be doing a contour because all of these cuts that we're making are going all the way through the material. So we're going to go ahead and select on that, and a dialog box will pop up here. And we're going to kind of step through the settings. The settings on these are fairly universal. These are the ones that you should probably use. The first thing we need to do is select our tool. So that's going to pop open a box. And the tool that we use on our Crawlbot can be found if you open up this samples menu. If you scroll all the way to the bottom, you will see that there's an option called Tutorial Inch. And it turns out that on this list, there is a 1/4 inch flat mill, and this fits the dimensions and the parameters of what we're using, and so this is the tool that we want to use, this 1/4 inch flat. It is possible to use other mills if you buy a different sized mill for maybe specialized work. Then there are other profiles that fit that, but for the cuts that we're doing here, we are going to stick to the 1/4 inch mill. So we'll go ahead and click OK on that. For coolant, we do not use coolant on the Crawlbot, so we can go ahead and disable that. We do run at a slightly higher spindle speed. That is 6,000 RPM, so we'll go ahead and change that. That will change some of these other parameters, and that's just fine. For our cutting feed rate, it's at 40 inches per minute. We have found that that works just okay. Our lead-in feed rate at 20 inches per minute is fine. Lead out at 40 inches. So these values are actually pretty okay. So we're going to stick with those. If you notice that it's cutting weird, you can tweak with these, but that would definitely be something to explore and read more about. But these settings should work. We're going to click on this next tab here called Geometry, and this is where we're going to be selecting what we actually want cut. Now there is a method that I suggest when doing this, and that is that we're going to work from our way kind of inside outward. And so we're going to start kind of with one of our inserts here, and what we want to do is we want to select kind of that bottom path that we would like it to cut. And so when we do that, if we select this bottom path, now you can see it kind of has an X-ray view, and so if I hover over here and click, you'll see that it's going to actually select that inside part of this insert, and I want to select the outside of it too, because I want to cut both the inside and the outside part of that. Okay, and we'll do that for each of our inserts, and make sure that you get both of those selected. Otherwise, if you forget to do the inside one, then it's not going to actually cut a hole in your insert. Okay, so we have all 4 of our inserts done. We're going to go ahead and start working out on our main body piece. So we're going to select this piece. Okay, let's come out further, and we're going to select our 4 holes that we'll have for the threaded rod. Okay, and again, you can kind of see where it can sort of approximate where that's going to be, and you can click on that, and then we are ready for that outside geometry. Okay, so this looks like we've gotten all of the contours that we want to cut. There's nothing here that isn't being cut, so that's good. And so we're okay there. The next thing that we want to do is we want to use tabs. So tabs are what are going to hold the pieces in place while they're being cut. If we did not have tabs, as soon as it was kind of done cutting through a piece, it would be loose, and what we have found is that a lot of times that means that they'll go flying because they'll come in just kind of the slightest contact with the end mill, and that runs the risk of ruining your piece, or even worse, kind of messing up the Crawlbot. So we definitely want to use tabs. And so we're going to come in here, and there are a variety of options for using tabs. The first thing that we need to adjust is our tab height. We want that to be 0.125 inches. That has been based on long experience about what works best for our Crawlbot, and so you'll want to set that for 0.125. Now the next option is the tab positioning. There are 2 options for that, and we'll kind of take an overhead view to look. Right now it's doing it by distance, and so it's placing a tab roughly about every 2 inches. And if we look around, it seems like that seems to be lots of really good tabs here. But we do run into one specific problem, and that's that we don't have tabs in some of these smaller holes. Now, because these holes are 0.6 inches, and we're using a 1/4 inch mill, this may not actually be a real problem. Most of what's inside these is going to disintegrate because it's going to get cut by the mill. So in this particular instance, it's okay that we don't have tabs in there. If these holes were any larger, we would definitely want to adjust our settings until we had tabs in there, because if there are small little pieces that are left over there, we don't want those to go flying off and to either damage our cut or damage the equipment. Now, looking at this, I do see one thing that I don't like so much, and that is that we only have one tab on these circles here. I'd really like there to be two. Now, what we could do is we could increase the tab distance. So if we go down to 1 inch, you see that we actually get 3 tabs here, and we actually get a tab on the inside here. But what we also see is we get lots and lots of tabs on here. Now, that's not necessarily a bad thing. It means that it would certainly be secured into place. But the issue that we can run into is finishing. That means we're going to have to cut out all of those tabs. We're going to have to sand them all down. And so 1 inch is probably too much for what we want to do. Now we could try maybe 1.75 and see if that makes any improvement. And you can see it actually really doesn't. It didn't add a second tab to that like I'd really want. And so if you run into this, there is a second type of tab positioning that is called at points. And what this allows you to do is to select your own tabs. And so if it just isn't working out the way that you want, then go ahead and you can click on different points, and it's going to add tabs for you. So I'm going to go through and I'm going to add tabs to each of these. I'm going to put them opposite of each other because that's just going to offer the most kind of support. And I'm going to come in here and we'll round out all of the tabs for our supports. Now I also need to come in here and tab this inside piece. So I would suggest when you are adding tabs to these curves is to try to add them to places that are going to be easy to get into and sand. And so this is a big, wide, gentle curve. And so I don't anticipate that that is going to be all that tough to get in there and sand off. And so I'm going to come in here and hopefully it will let me add a tab. So in here might be okay. Over here where it kind of gets a little bit more narrow, I may try to avoid a place like that because that may be hard to get in and sand with our tools. So I'm going to see if it will keep letting me add tabs. Okay, so as I've been messing around with that, you can see that it, for some reason, wasn't letting me add any tabs by hand to these outside pieces. So I've decided to just go ahead and with the single tab on these inserts. It's a little risky. When we did this previously, we had a problem with a couple of them coming loose. So if for some reason it doesn't let you add multiple tabs, it may be something that you want to be on the lookout for. But I was able to increase it to 3 inches, so you can see not a ton of tabs here on the outside that are going to be messing with me. So we're going to keep going on. Next thing, we're going to go to heights. Now, for the most part, there's not a lot we have to adjust here. The only thing we need to adjust is the clearance height here, and we need to set that offset to 0.2 inches. So if we have that set up, then we should be good. We can move on to the next. Next thing that we're going to change is in terms of passes. We're going to change the sideways compensation from left climb milling to right climb milling. This is just how we are set up to cut. And then we are going to click on multiple depths because we're not going to cut this all in one go. And so for multiple depths, we want to adjust our maximum roughing step down. A good kind of rule of thumb for this is half the diameter of your cutting bit. So we're using a 1/4 inch bit. So that means that our maximum roughing step down is going to be 0.125 inches. If we do that, then I think we should be okay. And so I think we can look at that as a good option for how to cut through this. We're also we're gonna try this order by island. So this should essentially try to cut things as from the inside to out. Anything that's an island essentially is going to get cut first. For linking, there's nothing here for this that we need to adjust, and so we should be okay to click OK. It's going to do some calculations, and once it has sorted out kind of a pathway, you'll notice that it gives this way of kind of thinking about how the Crawlbot's going to go and cut everything. You'll see that we actually have a little visualization of our tool here. And what we can do is we can actually, at this moment, let's go ahead and save what we've done here so we don't lose it. But we can actually have it do a simulation of how it's going to cut. And so if we click on the simulate button, that's this one right up here, what we can do is we can hit the play button and we can actually see what it's going to go and how it's going to go about and cut all of these pieces out. And so you can see it's kind of working its way around, and it seems to do a couple of passes along the way, and this may be because it's trying to just make sure that everything stays somewhat intact. You can speed it up if you'd like, and I really encourage you guys to actually watch through at least one simulation of your thing. A lot of times it can reveal if you've missed a spot or if there's going to be any issues with cutting your piece out. But once you've kind of finished watching your simulation, then what we want to do is move on to post-processing. And so if we come up to post-process, now this does require you to have installed the Pocket NC post-processor. This is the one that is compatible with our Crawlbot. We have a separate set of instructions on how to actually get that downloaded and installed for you. But once you have that selected, go ahead and click OK. We're going to go ahead and save this as our stool.nc. That is important. That's the file type that our Crawlbot understands. Go ahead and click save, and that may take a second to finish out. At this point, it's really important to go and look at that file and make sure that it has a decent size to it. So in this case, it's 202 kilobytes. If it's 0 kilobytes or a really low number, or if it says stool.nc failed or something like that, you may need to run that post processor again. If it does it a second time, what we have found oftentimes fixes that problem is actually saving your work and restarting Fusion 360 and then just running the post processor again. And that usually fixes 99% of the issues that we've had with it. But now that we have that NC file, we can save that and we can begin cutting on the Crawlbot. And that's it for this tutorial.